Welcome to the DAK Machine Safety Podcast. We support developing a safer, sustainable workplace. This podcast episode will address common safety myths that can constrain the development of feasible risk reduction strategies. The first myth is zero risk. The second is zero energy lockout. Third is the belief that all guards must prevent access. Lastly, the common belief that reducing the incidence of recordable and less severe injuries will somehow reduce the risk of serious and fatal injuries is a myth. This last one is tied to the pervasive myth of believing in the Heinrich triangle.
Isn't zero risk a good goal?
No. Zero risk is not attainable in any industry or in our personal lives. A goal of zero injuries is not the same as a goal of zero risk. Employers should not set targets for X number of injuries or illnesses. However, employers must also recognize that because zero risk does not exist, their best efforts might not prevent injuries related to hazards and hazardous situations that were not foreseeable.
If not zero risk, what is a reasonable risk in a workplace?
1976. William W. Lawrence published the book of Acceptable Risk, Science and the Determination of Safety. It took decades for industry and the safety profession to begin dealing with risk. In the 1990s, safety professionals were wrestling with tolerable risk and acceptable risk. The B11 series of U.S. national standards evolved to the use of acceptable risk. Listeners must bear in mind that most OSHA regulations are hazard-based, not risk-based.
Why aren't OSHA regulations risk-based?
The safety profession of the 1960s was firmly rooted in a hazards-based approach without regard to risk, a concept that was not even discussed. Hence, when Congress passed the OSHA Act in 1970, OSHA regulations were based on hazards without regard to risk.
Is there a correlation between risk and safety?
Yes. ANSI B11 defines safe as the state of being protected from recognized hazards that are likely to cause physical harm. There is no such thing as being absolutely safe. That is, a complete absence of risk. In turn, there is no machine that is absolutely safe. All machinery contains hazards and some level of residual risk. However, the risk associated with those hazards should be reduced to an acceptable level.
Is that issue similar to the myth of zero energy?
Yes, they are similar because there is no factual basis for zero energy. The term zero energy is not the same as the control of hazardous energy and is not found in any OSHA regulations and materials or U.S. national consensus standards. Of concern is how beliefs in zero energy or a zero energy state can negatively impact equipment design because many production, service, and maintenance tasks require some form of energy.
Where did the zero energy myth come from?
The American Foundryman Society developed ANSI Z 2441 1975. This document introduced the concept of a zero mechanical state, but it did not reach the broader scope of industry, nor was the document accepted as an American national standard.
Did any other ANSI standards or government agencies use the term?
No. ANSI Z 2441 1982. Personnel protection, lockout tagout of energy sources, minimum safety requirements, made no mention of ZMS or zero energy. In addition, a 1983 NIOSH guideline noted, maintenance activities, however, are always performed with some form of energy on and some form of energy off.
Why is the concept so widespread if zero energy did not have a foundation in ANSI standards or government documents?
This is a very good question, and one we can't answer other than people in safety who began to use the term, and it became embedded in our system of beliefs. For listeners on this podcast, be advised that there was no mention or any variation of zero energy in any of the following regulatory research or voluntary consensus standard documents: the 1982 and 2003 ANSI Z 2441 standards, the 1983 NIOSH Guidelines for Controlling Hazardous Energy During Maintenance and Servicing, the preamble to 29 CFR 1910-147, Final Rule for 29 CFR 1910-147, or OSHA's 2008-136 page CPL 020-0147.
Was the third myth something about guards preventing access to hazardous areas?
Yes. The third myth is tied to the limited situations where workers manually load a mechanical power press. OSHA and good safety practices require guarding that prevents entry of the operator's hands or fingers into the point of operation. If you do not distinguish this narrow requirement of OSHA regulation 29 CFR 1910-217, mechanical power presses, from the much broader tasks in today's world of automation, you will fail to distinguish the appropriate safeguard for a given task.
How and why does this cause problems?
Have you ever been in a discussion where engineering, safety, and operations are heatedly discussing this topic? It consumes far too much time based on the myth that all guards must prevent access. Guarding during normal production must prevent inadvertent exposure to a hazard.
On what do you base that assertion?
OSHA publication 3170, Safeguarding Equipment and Protecting Employees from Amputations, clearly states that machine guarding is intended to prevent inadvertent exposure. It mentions inadvertence 22 times.
What does the OSHRC Review Commission say about this issue?
The unanimous decision in the 2020 OSHRC Review Commission case involving Aerospace Testing Alliance reversed the judge and vacated a citation under 29 CFR 1910-212 A1 for allegedly failing to guard the hold-down pistons of a power shear. The case involved an experienced employee who suffered a serious injury to his hand after he intentionally circumvented the existing guard.
What did the commission rule?
The Commission's ruling noted, therefore the occurrence of the injury in this case does not by itself establish that the guard was non-compliant with 29 CFR 1910-212 A1. Although there is no dispute that the guard's design did not prevent the injured employee from intentionally circumventing it, the guard would nonetheless be compliant if the operator's actions were not reasonably predictable given the machine's normal operation. In other words, in a case such as this one, a compliant guard may not always, nor does it need to, prevent intentional exposure to the hazard.
Was the fourth myth something about the belief that reducing the incidence of recordable injuries will somehow reduce the risk of serious and fatal injuries?
Yes, numerous ASSP peer-reviewed articles have addressed the myth that reducing the risk of recordable injuries will somehow reduce the risk of low-probability, high-severity events, but the myth remains. A January 2015 peer-reviewed ASSP article, Preventing Major Losses, Changing OSH Paradigms and Practices, began with a summary of relevant ASSP articles, which noted, over time, industry as a whole has done a tremendous job improving its recordable injury rates, lost time incidence rates, and injury severity rates. These efforts are significant and worthy of recognition. However, many business leaders and employees still subscribe to the belief that by reducing recordable injury rates or lost time incidence rates, they are also reducing the chances that a fatality or other major loss will occur. This belief, or normalcy bias, is not supported by the lost facts from industry.
Do other credible sources agree with that premise?
Yes. That same peer-reviewed article went on to state, as Peterson, 2001 says, circumstances that produce the severe accident are different than those that produce the minor accident. Manuele, 2005-2008, and others have urged business leaders and OSH professionals to recognize that reducing the frequency of minor incidents will not equivalently reduce the occurrence of major loss incidents.
You also mentioned something about the long-standing beliefs about the Heinrich triangle?
Yes. Tied to this myth, and perhaps the basis for it, are those who still follow the now debunked Heinrich triangle. Another ASSP peer-reviewed article noted, Heinrich believed that the predominant causes of no-injury incidents are identical to the predominant causes of incidents resulting in major injuries. From there, safety practitioners posited that if they concentrate efforts on the types of incidents that occur frequently at the bottom of the triangle, the potential for severe injury the top of the triangle, would be addressed as well. Unfortunately, a review of available data indicates that this is a patently false premise.
Why is this an issue for alternative methods?
Alternative methods typically deal with exposures that could result in serious or fatal injury. Are the databases of recordable cases not good predictors of those exposures?
What about near misses?
Recordable injury databases will not predict the low probability events that could be high severity. We concur that near misses could be a predictor of such an exposure, but even that might miss the situations known only to workers.
How can we proactively identify the known unknown and unknown unknown risks in the workplace?
One way to quickly get input on exposures that could result in a low probability, high severity event is to ask your experienced worker about such situations. Workers can help identify such issues proactively, but they will only do so in an atmosphere of trust and openness to solving real-world problems.
What questions should I ask to get my workers to open up with candid input?
We've found that this question can help open a discussion of issues typically not addressed in an industrial setting. Ask, if your son, daughter, or close family friend came to work here, what task would you be most concerned about where they might be seriously injured? Identify the tasks and begin to talk about variables on a night shift, different product runs that cause jams, weather, etc. You might discover a goldmine of potential high-risk jobs.
Okay, there's a lot more to consider. Is there a simpler way to better understand all this?
Think about an automobile. When the engine runs, a mechanic is guarded against inadvertent exposure to the engine's moving parts. Now think about that mechanic troubleshooting a problem and setting the timing. He or she must intentionally open the hood to allow access. A safety rule equivalent to the inappropriate use of lockout would insist that the mechanic not have the engine running. Try that the next time you go to your dealership, and you'll have a real-world example of trying to impose infeasible means of safeguarding and the consequences of those ill-conceived policies. Thanks for tuning in to this episode by DAK Machine Safety. Today we debunked myths. In the next podcast, we'll deal with guarding versus LOTO, situations where workers are protected by a procedure such as lockout, tagout, or an alternative method. Keep the auto mechanic scenario in mind. It will help put things into context. You can support us by clicking like and subscribing. Take care, everyone, and until next time.